Hi there. In this video we're going to learn how to use the cosine rule to calculate an angle. So if you're watching this, you already need to know how to use the cosine rule to calculate a side, which is something we did in our class, and there is a video you can watch on that if you don't know how to do that. If you YouTube exam solutions and then cosine rule finding a length, it's this link here. And then you need to practice those too. So to find an angle, the formula that we use to find an angle using the cosine rule is just a rearrangement of the one we used when we found a side. So this one I've highlighted yellow. So as you can see there, if you pause the video, that can be rearranged to get this one here, which is the one we're going to use today. So cos of A equals B squared plus C squared minus A squared, all divided by 2bc. Okay, so here's an example. So I've got a non-right angle triangle with sides 4 centimeters, 5 centimeters, and 7 centimeters, and we're being asked to calculate the angle marked theta. Okay, so what's step one? Step one with all of these problems is to label the angles and the sides. And different people will approach this differently, but I always label the angle we're trying to find out as capital A, and then therefore the side opposite that angle is going to be labelled lowercase a. The other sides are going to be B and C, and it actually doesn't matter which order we label the other two sides, as long as they're B and C. So the key thing is that the two sides joining the angle, that's the 7 and the 4 centimeters, they need to be B and C. The side opposite the angle needs to be the A. Okay, so the next thing we do is we write down the formula, and the formula is good to memorize, but it will be given to you in the assessment. So here it is. So cos of A equals B squared plus C squared minus A squared over 2 times B times C. Now we're going to substitute in the information from this particular question into that formula. So instead of cos of A, it's going to be cos theta, and that equals B squared, 7 squared, plus C squared, that's the 4 squared, minus A squared, which is the 5 squared, divided by 2 times 7 times 4. Okay, now on a calculator, what's really important is that we get brackets in the right place. Now, you don't need brackets when you write the equation because the line here separates the numerator and the denominator and tells us we're working out everything on the top first and then dividing it by the answer to everything on the bottom. On a calculator, we need to put brackets around here, the top, and then around the bottom. Otherwise, we're going to get the wrong answer. Okay, so let's do it. So here's my calculator. So brackets 7 squared plus 4 squared minus 5 squared. Close the brackets. Divide. Open the brackets. 2 times 7 times 4. Close the brackets. So if I didn't use brackets there, say I just did this, then what's it going to divide by? Well, the answer is it's going to only divide by 2. It's not going to divide by what we want, which is the answer to 2 times 7 times 4. That's very important. Common mistake. Okay, now I'm going to go execute, or equals, and I get this answer. Now, this isn't my final answer. This is the cosine of theta that we've just worked out. I want to get theta. So what we need to do is we need to find the inverse cosine of that. So shift cos, and then just hit the answer key. So in this one, that means shift, and down the bottom, shift minus sign, and I get 44.42 degrees, the 2 decimal places. So theta equals, because it's not cos theta anymore, And in fact, I'm just going to round it to 1 decimal place. It doesn't matter really whether you go 1 or 2. Okay, so key process, I reckon the easiest way to do it, brackets around the top, brackets around the bottom, get your answer, hit Shift Cos answer, and then you're going to get it right every time. If we wanted it in radians, we could have either done it in radian mode. So if we actually convert into radian mode, by going, so I go Shift menu and then scroll down, change degrees to radians by going F2, and hit exit to go back. And if I hit equals like this, so now in radian mode, when I go Shift Cos of the answer now, it's going to give it to me in radians, so 0.775 radians. Or I could have just gone 44.4, and I could have gone divided by 180, and then times pi, and it would have given me it in radians then as well. And you can see the slight differences due to rounding. Okay, and that's just useful for you if your assessment's in radians, or if you're needing to use your answer in radians. Okay, so that's how to use the cosine rule. It's worth practicing a few. Always check your answer's sensible, and if it's in degrees, it's easy to do. We can see, for example, here that about 44, 45 degrees looks about right. The proof of the cosine rule is worth looking at too. It's something that we did in class together. If you want to see it written down, it's here, so you could pause the video and have a read of this. This is from the Theta textbook. It's not something you'll be asked to do in the level 2 trig internal, but it is a useful thing to know. And it's good algebra practice too. Okay, see ya.